All right, so this is Algebra 6.5. We'll be starting solving exponential equations today, and we'll take a couple of days with that, just like we took quite a long time for 6.1. But an exponential equation is an equation where some sort of variable expression appears in the exponent. So an example of an exponential equation is something like 3 to the 2x power is equal to 3 to the 6th power. And then since I have a variable in my exponent here, I could solve for that variable. And in order to solve for that variable in an exponential equation, both sides of the exponential equation have to have the same base. Once the bases of each power are equal, in order to solve for the variable, then we could set the exponents equal to each other. So since 3 to the 2x is equal to 3 to the 6th, the bases are the same on each side of the exponential equation. We have 3 as the base. If the bases are equal, then the exponents must be equal. So we could set up 2x is equal to 6 and then solve that equation. You solve this equation using inverse operations. Divide each side by 2. X is equal to 3. And then I can go back and check that. If I substitute this back into the 3 to the 2x, 2 times 3 is 6. So the left side's 3 to the 6th. The right side is also 3 to the 6th. You don't even need to evaluate 3 to the 6th on either side of the equation. 3 to the 6th has to equal 3 to the 6th. So x is equal to 3 is a correct solution to that equation. So now I want to take a look at a couple more examples of solving exponential equations. It says solve the equation and then check your solution. So on number 1, 3 to the 4x, let me try to get that focused a little bit better, is equal to 3 to the 12th. In order to solve that, so the bases on each side of the exponential equation are equal. The bases are each 3. So then I can set the exponents equal. 4x is equal to 12. And that should be a pretty easy equation to solve. Divide each side by 4, x is equal to 3. And it should check. 4 times 3 is 12. Left side is 3 to the 12th. And then the right side is 3 to the 12th. So that does check. On number 2, 8 to the x plus 5 is equal to 8 to the 20th. We already have the same base, so I could set the exponents equal. X plus 5 is equal to 20. And then solve that for x just by subtracting 5 from each side. X is equal to 15. If I substituted that back into the left side of the equation, 15 plus 5 is 20. Left side is 8 to the 20th. The right side is also 8 to the 20th. Maybe pause, take a couple minutes to try to work on problems 3 and 4 before we go over the answers together. So on number 3, you should have came up with x is equal to positive 2.5 or positive 5/2 by setting the exponents equal, getting the variable to one side of the equation, and then dividing each side by -2. If you check 2.5 on the left side, 4 times 2.5, that's 10, and then minus 5 is 5. On the right side, 2 times 2.5 is 5. So on each side of the equation, you have 6 to the 5th, and so x equals 2.5. It does check. And then on number 4, should have come up with x is equal to 0. Both of the bases are 5, so we could set each of the exponents equal to each other. 6x minus 3 has to equal -3 plus 4x. I got the variable to the left side by subtracting 4x from each side. And I added 3 to each side. 2x is equal to 0. So if you divide each side by 2, x is equal to 0. And if I check that on the left side, I substitute in 0 for x. 6 times 0 is 0. Minus 3 is -3. So the left side's 5 to the -3rd power. And then on the right side, if you substitute in 0, 4 times 0 is 0. -3 plus 0 is -3. It's 5 to the -3rd. Technically, you don't even have to make that a positive exponent. You would have on each side of the equation 1 over 5 to the 3rd. Both sides are equal, but 5 to the -3rd does equal 5 to the -3rd, so that's good enough to check that x equals 0 is the solution.